Welcome to Advian's webinar about quality assurance in the food industry. My name is Jonne Hirvonen and I work as a sales lead at Advian. On this webinar with my colleague Janne Honkonen, founder and CEO of Advian, we are discussing how to detect quality issues already on the production phase. With 9 use cases from the food industry, we will showcase how the smart factory approach to product quality assurance differs from traditional solutions. Hopefully, you will get ideas and insights on the ways automated quality control processes can improve production line efficiency in the food industry. During this 20-minute webinar, you have opportunity to ask questions in the chat. We will go through the questions in the end of the session. So let's get started. Quality needs to be ensured in every step of food processing and manufacturing. Contaminants, inaccurate nutritive properties, or poor hygiene can damage brand reputation. However, this opens opportunities for emerging technologies in food quality control. Edge AI platform enables integrated automated quality assurance and methods into your production processes. Hyperspectral imaging can reveal much more than contents of the food products than traditional methods. Hyperspectral imaging uses near-infrared sensors combined with spatial distribution to capture what regular cameras can't see. And hyperspectral imaging cameras combined with AI capabilities allows to identify anomalies outside defined quality standards. Edge AI platform enables capturing data with multiple sensors, analyze production in real time with AI capabilities, and control devices and processes in real time. On top of that, we have applications for industrial quality assurance, optimizing productions, app for preventive maintenance, and possibility to customize applications for customer needs. Here we demonstrate principle of hyperspectral imaging with concrete plum example. Machine vision manufacturers widely use RGB cameras. These cameras are suitable for characterizing objects based on their shape and color. However, since only 3 visible bands are available, their identification capability is limited. Hyperspectral technology may be used for more demanding applications to measure objects by recognizing hundreds of bands across the wide spectral bandpass. These bands are contiguous and are not limited to visible part of the spectrum. Hyperspectral imaging provides large amount of information, allowing to identify the materials based on their chemical composition. Each material has its unique composition and therefore reacts singularly to the electromagnetic spectrum. So we promised 9 different use cases to you today. Advian has implemented machine vision-based quality assurance solutions in the food industry many years now. Next, we go through 9 different use cases. Janne, would you please tell a little bit more in details about these use cases?
Thank you, Janne. Yes, my pleasure. So like Janne mentioned, I will showcase 9 different use cases, how food industry companies will benefit from these emerging technologies, Edge AI platform, hyperspectral imaging, and artificial intelligence. The most common use case in our discussion is analyzing the material composition. That seems to be one of the most interesting use cases for many customers. Whether we are talking about chemical properties or nutritive properties like pH, fat, protein, etc. Hyperspectral imaging has brought a lot of new opportunities compared to the traditional machine vision solution. Like Jonne mentioned, we are not anymore limited only red, green, and blue, those 3 bandwidths. We have almost 100 times more bands from near infrared, from the wavelength that are not available for the human eye. And that brings the kind of the edge AI combined with the hyperspectral imaging as a very fast, very precise opportunity to identify the material, for example, on a moving conveyor belt. And that enables you to make your processes more efficient and improve their quality assurance. One of the concrete use cases and examples is on the left. So there on the left we have meat with traditional RGB camera, and then on the right hand side we have the same stuff by analyzed with the hyperspectral. And of course the fat is available for you to see on the left hand picture as well. But on the right hand side, we have on the fly analyzed the fat content, which seems to be 15% in that material. So that's only one example. There's a lot of other examples. For example, fruits and vegetable quality control. If you are using those as raw material in manufacturing, that's one area where you can utilize this technology. Pretty similar is the kind of detecting the foreign material. In some cases, these are a bit overlapping with the previous one. If you want to kind of understand the bone residues, cartilages, or for example, some leather residues left in the meat. But also, in many cases, the customer, the kind of industry companies want to ensure that there is no wood, plastic, metal, or any kind of these materials within the kind of material you are selling. For example, in this minced meat, you don't want to have any kind of additional material. This kind of foreign material detection, it doesn't replace all the existing solution like X-ray. It's pretty much kind of comprehends the solution. For X-ray, you can easily identify metal within the meat, but with, for example, hyperspectral imaging, you can find wood particles, even small ones, within the kind of material. The third use case relates to the surface analysis. So this is not kind of, how to say, it's more like feeling. So that how attractive the product is for the consumer. So there's no risk like a metal in minced meat, but this kind of how well your products are selling. And there is a lot of different examples, like here we have a picture. When you analyze the coating of the donuts, how even is the coating? Or is there a kind of the jelly is coming out of the donut? Because you don't want maybe sell that kind of products to the consumers. Of course, in the baking industry, you want to analyze the degree of the baking when the breads are coming out of the oven. Are they too dark, too light? And utilizing the HAI platform that Jonne mentioned, we can also implement so-called feedback loop. So once we see that, okay, the bread cover is too dark, we can adjust the oven. Of course, the whole baking industry is more complex. So for example, one use case is what we have done is the kind of analyzing the dough surface temperature. So how the kind of dough looks like earlier in the process before it's coming to the oven. Even with that information, we can adjust the oven in the right way. Manual work. Although there's a lot of different automation solution and a lot of things has been automated, it's very difficult to avoid the manual work totally. And in those cases, the quality of the manual work is really dependent on the kind of individual employee. So there's a differences between employees, but also individual employee, depending on his own behavior, he might be more sharp in the morning than the evening or the afternoon, or he get tired towards the end of the week. So the quality differs even within the individual employees. And that's one case where this kind of new technology can come in the picture and understand and ensure that whether we are analyzing the bones left in the chicken fillet or the fat percentage after kind of manual kind of cutting, or if there's too much skin residues left in the chicken. So by analyzing these kind of things, we can both kind of ensure the kind of quality level to be stable, but of course we can also direct these kind of low quality pieces, for example, the rework. So if, for example, there is too much skin residues left, we can discuss with the automation and make sure that these pieces will go to the re-cleaning not going direct to the next phase of the production. Classification in many forms is very typical case. So depending on the sensor you use, even with the traditional machine vision cameras, you can do classification based on, for example, color of the object, color of the products, or raw material. When you take benefit out of the 3D cameras, for example, then you can start analyzing the volume of the objects. So what is the size of them? By utilizing hyperspectral camera, then you can see the kind of more detailed properties of the objects. But as this implies for the kind of fresh product, that you, for example, raw material coming in, it can be pre-processed product in the middle of the production, the waste can be classified. And maybe the 2 points to kind of highlight here is that we can combine multiple different sensors. So for example, if you utilize both stereo vision so that you can get the volume of the object, and you utilize scale, then we can easily kind of understand what's the kind of, I don't know if it's the right word, but how kind of, what is the kind of content of the, for example, some lettuce head. Try to measure, for example, that. Just an example.
Yeah.
And also the HI platform that we have, that also helps you to optimize the processes based on the kind of sensor data and AI as we just analyze it. We can actually control all the automation and making sure that you can kind of split all the kind of product based on the different qualities. Then food safety. Of course, there is an agency in Finland, especially in the Finnish market. This is not so much about the companies, but overall, for example, in EU is driving this kind of safe, nutritious, high quality and affordable food in a European region. And there the kind of main aims is to kind of prevent the diseases or different kind of pests, ensure the sustainable food production, increase animal welfare, etc. And how we can help companies here is that we can't replace the inspectors when the kind of law states that it has to be inspected by certain people. But what we can do with automation is help the work of the inspectors. For example, try to identify if there is some abnormalities, for example, in the shape of animals, or there you can identify bruises or something like that. So try to kind of make sure that we inspect the right animals coming in, or the products. Heat seal inspection, it's raising a lot of interest nowadays. So whether we are talking about minced meat, salad, whatever are the oil products that we are now packaging in a vacuum, it's kind of important to understand and make sure that the air seals are not leaking. Mean that if there is a leakage, of course, then the product is pretty much wasted when it comes back to the consumer. But here the point is whether utilizing traditional machine vision or whether utilizing hyperspectral imaging, we can ensure that there is no air bubbles in the heat seal, or there's no other kind of material left while you do the heat sealing. And maybe one point to kind of highlight here is that it doesn't matter whether your package is transparent or is kind of colored. Same technology works for both. Identification codes. This is also one thing. There's a lot of technology which is supposed to take care of that all goes right. But still, what we have seen and discussed with the customers, this is still an ongoing issue in many places. We want to make sure that we have the product information master data either in the mesh system or the product information systems. But still, we have to analyze in the production line that, for example, we have correct product name in the product, or we have the correct product code, or we have the right for whatever information you have. For example, for traceability, you might have some other information. For example, which tank was used in the beginning to make sure where it's kind of ingredients coming from. Date of expiry, that's kind of make sure that it's correct one. And sometimes your labels, for example, are not aligned with the package. Those are the things we can help with different kind of identification codes and names. And then last but not least, so the hygiene factors. The bacteria, you cannot distinguish that with an eye. You need something more, and that's a place where kind of new technologies comes in the picture. So issues we have seen is that, okay, we try to clean the conveyor belts, production lines, but still there is a residues of the previous material, or just in case we do a bit too much washing, and that way we are wasting energy and water, for example. But with the hyperspectral imaging, we can ensure, we can see what the human eye cannot see, and we can ensure that the hygiene level is good enough in both production line and transportation boxes.
Hey, thank you, Janne. So, as a summary, now we would like to hear about your opinion. Which one of these use cases Janne just presented to you would be the most relevant at your production line to develop further? But hey, thanks for your time and your attention. Hopefully, this was an interesting webinar for you, and you can download the ebook via this QR code. We have a lot of interesting content on our website, and we will contact you in future to ask more detailed opinion and feedback about this webinar. So thanks on my behalf, and Janne, would you like to say something to the end of this presentation?
No, thank you for my side as well, and happy to discuss with you in more detail.
Yep. Bye-bye.
Bye.